I don't want to demonstrate that, but if I have, suppose I have many of these, okay, then it will be very confusing, right? Everyone can send to everyone, right? You want to do it maybe 2 minutes? Let's see whether I have time. I don't think I have time, but you can imagine, right? That if I have, okay, this one maybe Ponsini, okay, this one maybe Apinya, something like that, and I throw everything in there. So everyone has to look, because, okay, maybe Arya, the first time you see this one, Ponsini, okay, and then the next packet coming in, you have to see, okay, this is Apinya, so you have to make different decision, right? Because you arrive, okay, now, okay, let's pretend this is Ponsini coming in first. This is Apinya coming in. See, you have to make the decision. This is the node that receives many packets, right? Okay, so if I throw like 10 of the packet inside of your network, okay, you will be confused. Actually, but you can work, okay, with the processing delay at the node. Okay, that's what I'm trying to say. Okay, now let's look at circuit switching. We don't have much time to play. For the circuit switching, okay, we talk about this already, dedicated part. So if you connect but you don't talk much, okay, you just, I miss you, hang up. Have you watched the movie, Boyfriend and Girlfriend, and you hang up first? No information at all, just wasting the... Anyway, but if you don't send anything, okay, during the connection, it will be quite inefficient, okay? You have delay when you set up connection, right? When I'm trying to set up the connection, okay, you hold the line, okay, something like, or dial up, okay, so you set up, so you waste some time, okay, you have delay over here. But when the connection is set up, no delay at all, it becomes one link, one direct link, and all signal can grow like there is one line, like there is no network at all. Okay, so network become transparent to the user. This is important. Okay, bold transparent to the user, which means that it's like you have a direct link from one source to destination. Okay, so no delay except propagation delay. Okay, this is circuit switching. Okay, so direct link. Now, why do we use it for voice traffic? Because we want constant transmission rate, and you want delay to be fixed and small. Because you want, like when you talk to your friend, maybe your friend in at Chiang Mai or something. Okay, maybe I want to go to Chiang Mai. Keep using the Chiang Mai. Okay, then you want to feel like you are talking face to face, right? You want to feel like you're talking to your friend face to face, even though you are far away, right? So you want the delay to be small, like when you talk and then they hear it immediately, very, very small delay, and also fixed delay. It's not that you speak this sentence and wait for 5 minutes, and then he listen, he got he hear it, and he reply it. Have you watched some movie about like astronaut? The astronaut, when they are on the spaceship, and then when they talk to the Earth station, they have made a lot of delay, right? They talk and then wait for 5-10 minutes to get for the other side to hear, okay, and reply. So another 10 minutes to get the reply, something like that. Okay, it's very long delay, but we don't want that, right? We want it to be small and fixed. So when you have direct link, is good, okay. Okay, in this case we have, suppose we want to call, okay, this telephone, okay. So you go to the end office, which is switching, a switch, okay. So this one getting in at this port, input port. You have to decide which output port to go, okay. Now you have to know if it's like 02, start with 02, and 942 is in this area, 915 is another area. If it starts with 034, it's in another province, something like that, okay? So you have to, when you look at the number, you will know that which output port you should link to, okay? Then we go to the long distance office. Again, you look at the number, you know which output port that you have to connect. So it's like you switch over here. In any of the input port and any of the output port, you can connect them, okay? But you connect them according to the destination number that you want to call, right? So you know you have to switch this way, and then low intercity trunk, okay? You connect to here. So this is a trunk. So this is an existing trunk, but you have to make a connection to use this trunk. You see what I mean? You have to make a connection here so that you will use this trunk. The trunk is already there, but you have to make correct connection at the switch, okay? You make a connection at the switch, use this trunk, and then you go to the correct destination. And so that is circuit switching telephone network, public telephone network, okay? If it is close together, maybe you end in the same end office, right? If you call inside Kasetsart or something, maybe you just use the switching box here, okay? Or you can maybe go to, depend on as necessary, okay? You go as further as necessary. Now the circuit switching concept, okay? We can, right now we sometimes use software, okay? But in the past, okay, we start with the space division switching, and then we have the time division switching, okay? For the space division switching, it's like this. You have the actual switch. This is the same as the picture here, okay? There's a node and input and output. So this is the same, okay? So you have the input and the output, so you make a connection. Now we will talk about the blocking switch and non-blocking switch. When you want to call, at first, okay, we prefer non-blocking switch. Non-blocking switch, because for the non-blocking switch, it means that, suppose we have 30 students here, it means that we can make maybe 15 input, 15 outputs, right? We can have for non-blocking switch, it means that we have to design the switch so that we can have 15 pairs of conversation at the same time. Okay, so depend on the number of inputs and output, okay? Suppose we have 15 inputs, 15 outputs, okay? And they are not, okay, one-to-one, okay? It's one-to-one connection, okay? So they're not one-to-many or many-to-one, okay? Just one-to-one, so you pair up, okay? Pair up into 15 pairs. Then for non-blocking switch, you must, the system must allow 15 simultaneously conversation at the same time, okay? You have to be able to talk at the same time and not interfere with each other, okay? And if you have like 100 input, 100 output, you also must be able, the system must be able to accommodate, 100 conversations, okay, at the same time. So that will be called non-blocking switch, okay? So now let's look at the number of patterns, okay, that we must allow it to, because if you have 15 input, 15 outputs, you can change, right, who you want to talk to. So the first person can choose 15 outputs, right, 15 destination. The second person can choose only 14. The third person choose 13, okay, and so on. So the first person can choose n outputs, any of the n destination. The second one can choose n-1 because the first one that the first person chose already, you cannot connect, okay, and so on and so forth until the last one is the last pair. So you have to connect to this person who is free. So if you look at this is n factorial. If you don't have n factorial permutation for the switch, okay, this is in mathematical terms, the switch must be a blocking switch. You cannot have non-blocking switch if you cannot have, if your switch does not allow n fact permutation. Now, for the blocking switch, even though it's a blocking switch, you also want it to be able to connect, okay? So, Puttapon, do you know everyone in class? Do you know everyone in class? Yes or no? Do you know everyone here? Yes, okay. So, you may have a chance to talk to any of them, right? So you want to have a connection, possible connection for every one of them, okay? So even though I say, okay, I cannot give you non-blocking switch, you say, that's okay, I can have blocking switch, but please make sure that I can connect to any of my friends, because I don't know whether I will have business with any who in the class. So for non-blocking switch, you also allow any input to any output, okay? Usually you will allow that. However, you cannot do it simultaneously. For example, you have 30 students here, okay? If maybe you can handle like just 10 pairs or 6 pairs of the conversation, but not 15 pairs. You know what I mean? You cannot allow all of them to connect at the same time. You may allow tens of them to connect, like 10 and 10, you know? So if you connect 10 and 10 already, 10 pairs already, the other 5 cannot connect at that time. But when any of the 10 they disconnect, maybe the rest can start to connect. So you kind of, you will have, it's like this. It's like the case that when you suppose you call your friend, and your friend say that he or she is free. However, the ringtone, okay, it's like it's like busy. But your friend say it's free. They're free. They're not using the phone. That is because it's blocked at the system. You know, like the switch, it's blocking switch is not enough to accommodate everyone. Okay. So that is called blocking switch. Now let's look at the space division switch. Implementing, this is the easiest one, is crossbar switch. The crossbar switch is the most basic, the first one, okay, that people use, okay. But it's not very efficient, okay, but it's the first. When you look at the old movie, and someone, an operator at the telephone center, and they have a screen, kind of a box like this, and they have like many, they will kind of have this. Okay, they will be at the screen, and they will do something like, this Mrs. A is talking to another board, maybe another board, or maybe and make a connection. It's like switch. The switching node in the past is like a person, and they have like many boards, and they have like connect this and this together, and this guy can talk. Have you watched like old movies, very old movies? Yeah, it will be like that. Anyway, so this is a crossbar switch. When you want to, so we have 10 inputs and 10 outputs, right? But when you want to make a connection as a non-blocking switch, okay, now suppose you want to send this guy, want to talk to this guy, the first and the second one, you have to make like a connection here at this cross point. So the cross point will be something like, at first it's separate, okay? When you make connection, then it touched. So when it touches, the signal can go. It's like closed circuit, okay? So at first they're all separate. They are on different plane. But when you want to, make a connection there, you make it touch, okay? So if this touch, then the signal go from here to here, okay? And suppose the second one want to talk to the fifth one, so then you have to make a contact here, right? You make a contact here so that this guy can talk to this guy. You can see that even though we have only 10 users, okay, as the input and 10 as the output, how many cross points do we have? How many do we need? How many cross points do we need to build? 100, right? So even though you use for maximum best case scenario, okay, you can connect 10 to 10, right? 10 input to 10 output. So you use only 10 of the cross points, even though you build 100 cross points. You build for 100 cross points, but you can use as a maximum 10 cross points at a time. Okay, which is just 10%. And what happens if, let's say, this is out of service? This is broken, cannot use. What happens? If this is broken, this guy, can they connect? Can they talk to each other? No, there is no other way. Even though you have another 99 cross points, you cannot use any other cross point to connect. So this is the weak point of the crossbar switch. Okay? You need a lot of cross points, and when something is wrong, let's say this one is wrong, something is broken, for that connection you cannot make a call anymore, even though you have a lot more of the other cross points that are free. Okay? So the crossbar that is a big, you see, is n square, right? The number of cross points is n square. So if it's big, it's not good, right? Bigger, the cross point is become bigger and bigger. However, if you use 2 by 2, 2 by 2, then it's okay, right? 2 by 2, you just have a cross point of 4. Right? You just have a cross point of 4, and instead of you doing building a big one, instead of making a very big crossbar switch, you will make like smaller one, right? 2 by 2, many 2 by 2, and then you connect together. You will connect together somehow to make it a big switch. Okay, so each of them will have just only 4 cross points inside. Okay, so this is 2 input, right, and 2 output, right? Okay, and then they have to connect somehow. Okay, so let's look at this. Oh, before we go to that, if you want to broadcast, okay, you can select many cross points at the same time. So one input, but go to many outputs. So you make contact here, so that it will go to all of the selected destination. The next one would be the multi-stage switch, okay, which is, I will talk about next time, but you can see that it's like you have, like many Legos together, 2 by 2, 2 by 2, and then, okay, and then you have to connect. You have to connect them somehow, okay, so that they will go to the correct destination. So you will build a big one using multi-stage switch instead of one crossbar switch. Okay, thank you. Okay, that's it. ขอบคุณค่ะ